Well, today we have this early to mid 1960s General Electric clock radio, AM clock radio, and I found this in the garage in a kind of a cabinet thing on the farm a while back, and I'm not exactly sure where it came from. Obviously it had been there for many decades. That garage was built in, I believe, around 81, and this thing is much older than that. I don't remember this growing up. I wonder if it's something my parents got for a wedding gift in the early 60s, and for reasons unclear stopped using it. Don't know. At any rate, we're gonna check it out today. Actually, other than being dirty a bit, it's seems to be totally unmolested, broken, etc. I mean, you can tell that this hasn't been plugged in for a very long time. So what do we have here? Does it say it's a model C-403G in white? Yeah, gives a little information about it on the tag here. Definitely wouldn't have been a high-end item back then. I mean, I don't see any, other than it being dirty, the only thing I can see, there's a little chip out of the corner of the clock bezel here, and a little bit of corrosion on the metal inserts. But yeah, it doesn't look like it suffered any other type of damage, so one wonders what was the story with it. So what I'll do is I'm gonna plug this in using a power meter and check it out. I would expect this is a tube radio and probably series string. Don't know if it uses a silicon diode for a rectifier or not. Yeah, if the thing is somewhere around 60 years old, it's going to have probably dried out caps, so if we get anything out of it all, I will not leave it plugged in for very long at all, and we'll see what we get. Okay, I have my kilowatt here, and I have it set to display current, and we're going to plug the power into the clock radio. The switch for the radio switch is off currently, and position that there. So what I do notice is the clock motor has started up. You can see the second hand is sweeping, and I don't hear it making any growling noises, which usually you could hear those if the motor is kind of worn out, and so maybe this doesn't have a whole lot of hours on it. And I mean, this is not very accurate, low currents. It's saying like 30 milliamps. So let's turn on the switch here and see what happens. The current draw has not changed at all. The clock is still running. Current draw has not changed. I would expect that if the tube filaments are heating up, we would get a surge of current here, which we are not. Let's just turn this volume control up. It seems like this is dead. You know, maybe that's why it was put away. Although back in the day, you know, people used to get stuff fixed. I remember my parents having, you know, electronics fixed all the time. You know, that was a service guy that made house calls even. Mr. Turner would come out to the house to work on your TV set. Alright, yeah, it's not drawing any current. I don't hear anything. Turn this back off. Looks like we'll have to pull the back on this to do a little bit of troubleshooting and see what we find. Okay, we're going to pull the back off of this. There's no screws holding the back on. It's just this fiber board. Has a tab here, and I think another one right there. And then it's held on by the tabs on the plastic on the top. And you can see that there's some, the fiber board has tabs. So in order to try to prevent anything from breaking, I got this plastic pry bar that mostly these are sold for taking trim panels off on cars, but seemed like it should work for this as well. And I might need to have, yeah, I think this is a two-handed project. So I'm going to go and remove the back, and I'll be back shortly. Back came off pretty easily, no real issues there. This is one of these things that has an interlock, and the way the interlock is done is the cord, disconnects from these two pins here when you take the back off. I mean, the idea, of course, was to prevent the user from poking around in here with live power. So what usually ends up happening is service people back in the day used to have a separate one of these cords that they could just plug in here, and they would call that a cheater cord because it cheated the interlock. What we'll end up doing is getting this little metal clip off of here so that the cord will pass through the hole in the fiber board, and then we can plug it in directly when we get to that point of maybe doing some electrical tests on this. So before we get into that, if we need to get into that, I guess one of the first things I want to verify is if that power switch is working, the front power switch that would turn the radio on, if that's working or not working. Because maybe the problem is right there, and it's hardly any need to go any further. Now this electrolytic cap here is very likely dried out, but yes, this is a tube radio. And how many tubes do I count in here? I think I see 4. 1, 2, no, there are 5 tubes, so maybe it uses a tube for a rectifier and it's not a diode. I'll have to try to find a schematic for this. I'm sure one can be found fairly easily online. Yeah, there's a circuit board in there, and depending on what we find with the power switch, we may end up having to pull that board out. Now I see there's a chunk out of the corner of that board. I wonder if that has always been that way. The circuit boards on this vintage of consumer electronics they're not very good, and I have another radio than my Q that is similar to this one. I mean, it looks almost the same except no clock in it, and it was out in our dairy barn for a long time, and it quit working. And some years ago I found it in a shed on the farm and started to take a look at it, and the circuit board on that one was actually, well, on that radio it was mounted at an angle like this, not up and down like this one is, and the whole thing had warped and like shrunk away, pulled away from these power pins. I'd like to get that one going again. I have fond memories of doing chores out in the barn, and Dad would always have the WCCO radio on in the evening while he was doing the milking. My recollection is it got a real garbly sounding, and eventually they just took it out of service and got another radio in there. At any rate, we'll see if we can't. So it looks like power switch wires got to be down under there, and I'll see how hard that is to get at those. Yeah, we'll do some continuity tests here right away. Okay, I tried tracing. There's two wires that look like they must come off the switch. There's a short white one that goes up to the motor winding as a jumpered spot, and then that goes over to the circuit board. And then when I looked at the circuit board, I could see that there's a trace that goes up to the power pin here from the AC power. So power comes in, goes up there, and then jumpers down to, I'm assuming, the switch. And then this blue wire is on the other side, and it goes back somewhere on the board. So what I've done is I've clipped my ohm meter on the one power pole, and then what I'm assuming is the other side of the switch. Alright, so I've got that is open. I'm going to reach around the radio here and turn on the switch. Boy, that's kind of, it should go to a very low value and not be, I think that's the automatic setting. Off, on. Yeah, that's like way too high a resistance to, maybe that's what the problem with this thing is. Maybe the switch is bad. Feels a little floppy in my hand as I'm wiggling the knob around. Maybe it's possible to get some contact cleaner on it as well. But yeah, that's just, for a switch, that's too high of a resistance, and it's not very stable. It tells me it's not right. It might just be that it's corroded from sitting around, or it's bad. I just poke at it here. Sometimes it'll settle out, but 37 ohms is way too much, I think. All right, how do you even get that clock mechanism out of there? I don't see any screws. I'm assuming the bezel on the front would have to come off, and there's like plastic tabs that are holding it in there, because I don't see how you can get at the switch on the bottom. It's just too buried in there. Yeah, maybe I can find some service information on this that gives me some hints here, because yeah, now it's like up to 115, and just to make sure my leads aren't the problem, let's get that off of here and touch that one here, touching that one, not the problem. There's something going on with the switch. Okay, I'll figure out how do we get at the switch. Although if I want to find out if the radio works, I'm sure we could jumper around said switch. That wouldn't be a problem. I might want to check a few things before doing that, though. Okay, found out where the blue wire goes. So we knew one end of the switch has to be this blue wire, and it goes on the board, and I believe it is poking through where I have my clip lead on, and then so then the other so we got one end of the blue wire here, other end back there, we have 0 ohms. Okay, so that's where the blue wire comes out. And I'm looking at this, and I mean, they're a one-sided board. We'd call a one-layer board nowadays. And the blue wires poke through there. It looks like it's common with one of the 3 pins on this red cap. And then what's interesting, I was kind of following the traces around in here. It's actually tied to this here, which is the frame of this transformer. So that's interesting. Yeah, so maybe that's the neutral, what's considered the neutral on this board is that pin, because that would be like the common pin of the capacitor. It's going to have one common, and probably is it a kind of looks like from the markings this is like a 2-section cap, so it'd be like a common ground or a common neutral there. So I think what I do is we'll just bypass that switch and see if we can power the radio up directly. Yeah, I still think I should see if there's a schematic for this, just find out if it's using a tube rectifier or not. I wouldn't want to have this cap be shorted and then I'm applying power and then it blows up my rectifier diode. The tube one, I'd be able to, take some more surge current. It might red plate, but I can keep an eye on that. So let me go see if I can't find a schematic for this thing, and then I'll look at how can I jumper around that apparently bad switch. Well, Radio Museum has a page for this radio, and there it is. According to this, these were from 64 to 66. Unfortunately, they do not have a schematic for it, although there is some information here. It gives the tube lineup, just a few things about it. There's a lot of similar models that were made for a few years, so there's a little chart here. However, this I believe is the rectifier tube, and I've already pulled up that page, and yes, it is. This 35W4 is the rectifier tube, so it doesn't use a silicon diode or germanium diode for the rectifier. So this tube is the rectifier. So it might be fairly safe to just apply power to this thing and see what happens. From what I've been reading about this radio, there aren't really probably aren't any other E-caps in there except that red one, and it kind of looked like everything else might be ceramic. We'll take a closer look at that though. So see if there's any of those wax paper caps. This thing has been out in an unheated building for decades. That a lot of wild temp swings, humidity swings, etc., etc. So I'd fully expect any capacitors to have soaked up plenty of moisture over that period of time. Alright, I've jumpered around the switch with this red clip lead pair, and I removed the power cord interlock from the back and plugged it here directly. And once again, I have my amps. I have my this guy here. What do we got this time? Is our current higher? A little bit higher. Would have expected more than that though. Is it more than a bad power switch? I do not see any glowing here. I think I need to use two hands before I get a shock or something if I'm not careful. Alright, I wasn't having a whole lot of joy with this. I did try wiggling all the tubes in the sockets, and under the theory maybe there's a bad connection. Then I found one of them that may not have been plugged in the socket correctly. So I did plug that one in. Didn't make any difference. So I pulled all the tubes out, and I don't know if that's normal, but these two of the sockets are just these metal clips on there, and it's actually hard to get the tube in correctly, and it wouldn't feel very tight. The one right here was the one the tube may have been not plugged in right. So I thought I was onto that. Maybe it was in the wrong spot. There's another one back there. It's a similar one. And then I noticed, it's really hard to see back here. There's another socket back there that may be the same, but I noticed it's got like a plastic disc on it, where these other two don't. I wonder if it's broken off or fell off, or who knows. I mean, there's a little bit of discoloration of this board, so you can tell it has been used at some point. You know, the hot heat from the tube, especially the one back there. But there's 2 and possibly 3 kinds of sockets here. So I have all the tubes out, and they are all GE branded tubes, most likely originals. So what we're going to do is we're going to put all these on the tester here. Mostly my motivation is just to see if we have any open filaments. Yeah, I know you can check them with an ohm meter, but then I got to look up the tube chart to do that. And this is just easier, and I can do an emissions test at the same time as long as we're doing it. All right, let me grab the first tube and we'll get going. All right, I put the first tube in here, which was a 12BA6, and per the chart, got all my switches set up. I got the tube in the proper socket. So I guess we start off with an emissions test here, and we'll see what happens. I see the tube starting to glow a little bit. Emissions are coming up. And this one says it's a good healthy tube. Doesn't surprise me. Then there's a grid leakage here. Grid leakage is good. Shorts test. Alright, so emissions off. I suspect all these tubes will be just fine, and we got some other problem. Alright. We move on to the next tube. Well, the second tube is this 12BE6, and initially the emissions seemed kind of soft, and then it only came up just past the question mark. And then when I did the leakage test, it looked good, then it went bad, and then it was like, I don't know, jumping back and forth a bit. Like that, only all the way down and all the way up. And I've let it warm up some more, turned it off, returned it back on, made sure the socket was wiggled. I mean, it's obviously heated up, so it doesn't have an open filament. See, it was doing that. So I'm not sure what's up with that. The emissions look better than they did initially, but then we have this leakage test, which now is good, but then sometimes it goes bad. I have heard that these Sencor testers have, they can maybe a little too sensitive on this grid leakage test. I have read that. I guess I can't comment on it. At any rate, my main goal with this was to identify if we have an open filament on one of these tubes, and this one doesn't. Maybe we got other problems, but can't get the radio to power up to discover what those might be. All right, I'm going to move on to the next tube in the list here. All right, moved on to this 12AV6, and if you look at the chart here, it looks like we actually have three elements in here to be tested. So we'll start with the first one, and I've got the switches set for that. Let's go ahead and turn on the emissions test part of it and see if it lights up here. Looks like our meter is starting to respond. It goes up to the good. I should probably look up what kind of a tube a 12AV6 is. Maybe that's leakage there. And there's a short, there's a neon bulb for shorts here. We'll go back to the emissions on that. And then when you look in the chart, so switch D has got C and D, is your two tests here for two of the elements. So let's move on. We're in C now. Go to D. And that looks about the same. Alright. And then the third test is a bunch of other stuff changes. So let me turn this back off and then we'll set that. So if I'm looking at the 12EV6 over here, voltage remains the same, but switch B goes from G to F. G goes to F. And then we got still 5, and then now we're on position A for that one. Alright, let's do the emissions again. We already know the filament on this one's not open. Okay. Our grid leakage. I wonder if I should look up what this was. I wonder if it's like two triodes and a diode or something in there. I don't know. All right, don't have an open here. Let's continue on. All right, it's tube number 4, which was a 50C5. So I had that's a 50 volt filament tube, which is the switch over here. So 50C5, we got 50C3B, we got 50C3 and B, right? Okay, let's do our emissions on that one and see what happens. And I see there's some needle movement now, so it's warming up. Definitely not open. Yep, it's up in the good. I think this is your audio power amp tube. I want to say I've seen this on other things used to drive the speaker, so I'm pretty sure that's what this is. All right, our grid leakage is good, and no shorts. All right. And finally we got the one last tube, and we'll do that one. Okay, the last tube was our 35W4 rectifier tube, and I got all my switches set for that one. Let's see about this one. Is it gonna work? I see the needle starting to move. Very slowly. And it's kind of stuck in the bad there, isn't it? Do I have something wrong? So this should be the 35. Is it heating up? Alright, 35W4 says switch for 35 volts. That's this one. B is B. We're on B. And next one is position 4 and then C. So that's like 4 and C here. So this is this one could be kind of dead, but on the other hand, the filament's not open. Otherwise, we wouldn't get even that. Grid leakage is the same as everything. It's not very warm either. It's been on a while here. I'm kind of wiggling it in the socket here. Let me check a few things. Well, it kind of looks like maybe my tube tester took a dive here. Interesting. So there's no tube in here at all, and on emissions now we have our needle where it was when I had that tube in there. if I turn the tester off, it goes to 0, and then it comes back here. Well, this is an unfortunate development. I hate to have to. Now I'm going to have to check into what's up with this tube tester. It used to work. Well, it was working initially here. I mean, I don't use this very often. There isn't much in these. I tried changing a bunch of the switch settings, and it's still the same. The only thing that I ever remember when I've had this since probably close to 30 years, and I even have the original box from it. It never was used very much. I put a new capacitor in it many years ago, and maybe that's gone bad now. So unfortunately, we're gonna have to probably call the effort on this GE. Put that on the back burner or back on the shelf for now, and until I can finish with. I guess I can check the filament of that 35W4 with a meter, and we'll see if it's open or not. Because it never warmed up either. I noticed this. It never seemed to get warm. So yeah, we'll start with that. Maybe it is, and maybe that's the problem right there, and this thing with the tube tester is just another problem. All right, this is weird. So I went back to the 50C5, all the switch settings for it. It's in the socket, and okay, now the meter is showing like it did. Good. Grid leakage. And then this shorts test doesn't really move the meter. I don't remember what did it do before. I'll have to look back at the video. Now that's dropping. Is that emissions dropping? So this tube's hot. It's warmed up. Maybe too warm. It's pretty warm. The 50C5. I don't know, this is all very mysterious. When I had the 35W4 in there, it didn't even seem to be getting warm. I don't know if this is too hot or not. It's hard to tell with this kind of thing. I thought the emissions was a little higher earlier on this one. I wonder what's going on. Let's go back to the 35W4, I guess. Okay, the 35W4 is back in here again, and it's behaving the same way it did the last time I had it in here, where the meter comes up a little bit on emissions test, and I do not feel this heating up. So maybe the whole thing with the meter is just the symptom of the filament not heating up, and it's applying bias voltage to test the tube, and the heater's not heating, and that's why you get this weird reading. I actually have the manual for this tester somewhere, and I haven't seen it for years. I don't know where it is off the top of my head. Let me get the tube charts, and we'll see if this is a bad filament in this. Because if that's the case, that would be the reason the radio doesn't work, or at least doesn't seem to power up at all. No current is being drawn. All right, I gotta go find. I do have a tube book around. Let me go find it. Alright, found my tube. Actually, it's a tube substitution book, but it has a basing chart in there. So I looked up the 35W4, and it told me that it goes by this diagram here, which is a 5BQ diagram. And I guess I could have looked at that web page that we looked at earlier in the video, because that has the same information. And what it says here is the filaments should be pins 3 and 4, and typically these charts are from the bottom, not the top. Like if you were looking at modern ICs and what have you, they show the pin out from the top of the part, because that's how you're looking at it on the board. On tubes, they always show it from the bottom, because usually folks would be probing the tube socket from the underside, the bottom side of their chassis. That's why they do it that way, to you know, just to make it easier for the way you're going to look at it. And this is just about impossible to do on camera, but I did check 3 and 4 here, and then just in case I was wrong, I unchecked 3 and 4 over here as well. But actually I did look at the tube. You can see where things are hooked up in there, and it is the correct ones would be 3 and 4 right here. And so I used my meter to do that, and for sure it does measure open circuit. I don't know where the break is. You don't see it on where the wire is attached to the pin coming through the glass. That doesn't look broken off, so it's obviously broken somewhere, you know, where it passes. There's some, you can't really see this on camera very well, but there's like a white coated wire that slips into the long tube that goes up inside, under, you know, inside there. And so there's a break someplace in this tube. I don't know if I have a 35W4. I might. Unfortunately, all my tubes that I have are in some boxes in the loft of my garage, and probably a little more ambitious of a project to go digging around up there right now than I want to. It's very, very cold out, and I don't feel like crawling around up there this afternoon trying to find it. So this video is gonna probably have a part 2 if I can get my hands on another one of these tubes. I'm kind of loath to like order and buy a new one until I know if there's something else busted in here. So I'd like to see if I have at least a usable 35W4 kicking around before we go that far. Looks like all for now on the video.